Good afternoon, and thank you for joining today's webinar with SPEC Innovations. Today's webinar is titled, Using Innoslate's Test Center for Integrated Lifecycle Verification and Validation Planning and Execution. My name is Joanna Moore, and I'll be the moderator for today's webinar. Let's go over a few basics before we get started. During the presentation, feel free to send us questions using the panel on the right, and we will get them answered in the Q&A section of the webinar. The webinar is being recorded, and we will make it available to you after the live presentation. Now I'd like to present to you our very special guest presenter, Dr. Jerry Sellers. Today he'll be showing you an end-to-end case study for planning and executing a complete validation and verification plan using Innoslate's Test Center capability. Dr. Jerry Sellers is the author of Understanding Space, an Introduction to Astronautics, a contributing author and editor of Applied Space Systems Engineering, and a contributing author of Human Spaceflight Analysis and Design. He has over 30 years of space systems experience, including guidance and onboard navigation officer in Space Shuttle Mission Control, partner of Teaching Science and Technology, Inc., and Jerry is a member of the Lifecycle Modeling Language Steering Committee. Jerry, the floor is yours.
Well, good afternoon, good evening to everyone, wherever you're dialing in from. As Joanna said, I'm going to talk about a case study we did with using Innoslate for verification validation planning, specifically for a little satellite system we use in teaching some courses all around the industry. So let's go to it. So Joanna's already introduced me. That's what I look like. So I don't think we need to say any more there. This was the abstract we sent out. I think you probably signed up based on what that says. So let me tell you what we're going to cover here today. I'm going to give you a little background on the project itself, so you kind of know what it is and kind of the scope of it. And then I'll talk about how I use Test Center to lay out the verification planning and highlight some of the outputs that came out of Test Center that we use all the time in our classes. And then I'll finish up with another example we did, which is showing how we can use Test Center along with LabVIEW to do an end-to-end automated testing scenario. And then we'll wrap up and see where everyone is with questions. So this system that we're using goes back about, gosh, almost 20 years. And it was actually developed at the Air Force Academy under the name ISAT. And the Air Force Academy's mascot is a falcon. And so a baby falcon, it turns out, is an IS. And so we called it ISAT to be a baby falcon. What we were looking for was a desktop satellite that we could use to train people on how to build satellites, because obviously satellite hardware is extremely expensive, and it'd be nice if we had something a lot less expensive that people could kind of cut their teeth on, and that's kind of where that originally came from. And then our latest iteration of that system, which we've had now for about 5 years, is called ISAT Cubed. So it's based on what's called a CubeSat platform. So CubeSats now are kind of a popular platform for use for a lot of small satellite missions. So if you follow space stuff, about a week ago, SpaceX launched something like 60 satellites, and most of those were CubeSats. So pretty popular platform size anyway. So for our mission, we created a fictitious mission we use as an example of how to take this hardware and software, which is a desktop satellite, and we built a mission around it. And so the mission scenario here is a nano satellite for basically taking weather photos. So the argument here is that we have a basic need. So here's how I'm starting to show how we could use Innoslate to trace from the very beginning of the system engineering process, which is tell me your need, all the way through verification. And so we start with a basic need. You can see on the slide there. So the government needs a rapid response gap filler capability. So the idea is that you could launch these relatively inexpensive CubeSats, and they could take weather pictures that are obviously not as good as the multi-million-dollar platforms, but might fill in the gaps in certain parts of the Earth when you need it. Then we went ahead and modeled the goals and objectives for this mission. And so this just shows a hierarchy chart coming right out of Innoslate for what those goals and objectives are, which then map directly into the requirements, as we'll see. Other thing we model, of course, is the concept of operations. So this is a diagram right out of Innoslate. For simplicity today, I took all my diagrams and put them into PowerPoint just to make it smoother rather than trying to bounce back and forth between the tool. But if any of you who've used Innoslate know that any of these diagrams are really rich diagrams in that there's metadata that can be associated with anything you see here. So here's an example of my ConOps that shows, for example, the interface between the satellite and the ground, and that little lightning bolt interface, not just a pretty picture, it's actually a diagram in Innoslate. So that lightning bolt actually represents a data link, which has a specific frequency and data rate and other things associated with it, requirements, you name it. So that's kind of, again, that power of modeling, is that we get to have that richness, that what I say is the other dimensions here that you can't see just in a 2D PowerPoint slide. But this gives you the overall breadth of how this mission notionally would get performed. Here's our little CubeSats taking pictures along with other satellites out there in the constellations and sending that data down to the ground. So because we think about life cycle modeling, so we have our goals and objectives, we have our concept of operations, and then we start developing our requirements. And so we kind of have a relatively simple requirement structure shown here in this in this diagram, spider diagram. And so we have our system requirements broken down into 3 subcategories: characteristics, capabilities, and interfaces. And then you notice what's going to become important here as we go along. I show a verified by connection. So we have our design requirements and we have verification requirements, and we'll talk about how that gets modeled all the way through this particular system. So here's our actual hardware that we model, and the desktop satellite you see here has a backbone shown in the center picture, and then around the sides you see all the subsystems that basically plug into this. If you notice, there's sort of a backplane there, and there's connectors that plugs into. So again, this is what's called an asset diagram out of Innoslate, and notice if you look along the bottom of each picture, it says decomposed, and so if we were in the model, I could click on that little decompose banner, and that would take me one level deeper into the system architecture, which I find is one of the great benefits of modeling, is that it gives you this, what I call zoomability capability. I can look at high level, or I can zoom down to low level, I can zoom back out to high level, and I have the ability to very quickly go, kind of navigate around my system, high and low level, to understand what's going on. So this shows how the various subsystems come together to make the overall system. So, and then this shows an internal block diagram of the system. So now we know where the connections are, and we actually built lower level block diagrams as well. And the block diagrams help us kind of start to have the conversation of what our schematics are going to look like. Block diagrams are not a substitute for an actual board schematic that you'll need to spin the board, but this helps us define the requirements for that board schematic. And then we also modeled our ground support equipment. We use that to build up our packing list. So we actually generate our packing list directly from Innoslate, because we teach a course using this hardware all around the industry, European Space Agency, NASA, other places. And so we have to literally pack up everything and take it sometimes halfway around the world. And so having a good packing list is helpful. And we use Innoslate to keep track of all the odds and ends that we need to bring with us, right down to the connectors and things. The other piece of our ground support equipment is this software called SCOTI, which stands for Spacecraft Control of Operations Testing and Training Interface. But it's a LabVIEW based a graphical user interface that allows us to do command and control during the test phase. It's designed to be extremely simple to use, because we do a version of this course actually for DoD, and we bring in people with basically zero space background, never touched a satellite in their life, and they get up and running on this software pretty quickly, so we can get them actually testing the satellite on the bench, even though they don't really have any satellite testing background, which is kind of fun. And we'll talk about how we use this SCOTI later in the presentation. So when we do verification, and regardless of whether you do model-based verification planning or do it any other way, the process is basically the same. So it starts with the requirements, what I'll call requirements engineering. So I have to develop my design requirements and then develop your verification requirements. And so the verification requirements capture how are you going to verify each design requirement. And there are 4 classic ways of doing that, through test, analysis, inspection, or demonstration. And then once you have requirements that are, they're verifiable, you can go through a validation process of those requirements. And the quality quality check that's built into Innoslate is actually really handy for that, because it'll go through and actually look at your requirements against 8 parameters. I think there's 6 of them it does automatically. And one of those is verifiability, and at least gives you some feedback on that. And then within Innoslate, as we'll see, we'll attach a label to each requirement that says the method or methods of verification we're going to use. So once we've converged on a valid set of requirements, then we can do verification planning. And that verification planning, as the diagram here shows, is informed by what I would call the verification philosophy. So if I'm building a little CubeSat that may or may not work, and I only have a tight budget, then I may, not do as thorough a verification as if I'm building the NASA Space Launch System, which is a multi-billion-dollar program. I'm going to spend a lot more money on verification and do more analysis and more testing, right? So different projects are going to have a different scope in terms of how they approach verification, and that informs how we do our verification planning. But it tends not to be very productive to do verification planning until you have a valid set of requirements. If anybody's ever tried to verify a poorly written requirement, it's very tough. So we want well-written requirements before we dive into that verification planning. So here kind of shows kind of a top-level view of how you can model out what has to get done in terms of your verification planning. So you're going to have a design requirement. So I showed it here as anything that begins with a 3 is a design requirement. So for example, on a spacecraft, you have a requirement for natural frequency, because if you vibrate your satellite at its natural frequency, it'll resonate and blow apart, and that's a bad thing. So we're going to verify natural frequency through a verification requirement. So I have a verified by 4321 there, which is verification of natural frequency. Now that's going to be verified 2 ways. Can be verified by test, and it's going to be verified by analysis. The analysis will have us go off and build a finite element model, and then we're going to go use that to do a first mode analysis using a finite element model. I'm also going to verify by test, and I go down that left branch, and so I come up with a test case, TC110, which is the baseline modal survey test, which is going to get performed at one level deeper through what's called a set of sign sweep assets. So I'm going to have some things that I need. We do what's called a sign sweep modal survey to tell us what the natural frequency of the system is. And to do that, I have to have a vibration table and an instrumentation and a space vehicle to vibe table adapter and some other stuff. And so that planning happens from the top down, all the way down to the point you're enumerating the various things you need to perform the test. But here's where what I call the snowball effect of verification starts to kick in. And I highlighted that SV to vibe table adapter, which is essentially a piece of metal with some holes in it. But that piece of metal with holes in it has requirements. It has to be designed. It has to be verified. And so you need to verify the things that you use to verify other things. And because of that, the snowball just keeps growing as I roll it downhill, which means the scope of the verification effort just seems to grow and grow over time, because we keep forgetting things that I have to verify. Oh, I got to go verify that. Oh, I have to build that. And again, here's where modeling, I think, really helps to save the day, because by keeping track of all this, I can at least know the size of the snowball. It's not going to make the snowball any smaller necessarily, but at least I can keep track of the snowball as it rolls down the hill. So the way we execute this then in Innoslate is, it all starts with our design requirements. And so the first step is to go through our design requirements. Hopefully they're good design requirements. They've been validated. And then I'm going to put, in Innoslate, I'll go put a label. And so it's one of the default labels in Innoslate I would just apply here at all. I put a label that means requirement, so that just helped me sort through, so they all have a requirements label in there. But I happen to pick 3 requirements that are going to be verified by inspection. I have plenty of others that are done by test and some that are demonstration, but this slide I just happen to randomly pick 3 that are all verified by inspection. So I put that label in there in Innoslate. And then I realized I have to now connect my requirements to what I'm going to call verification requirements. Now, the way I did it here is not the way you necessarily have to do it. It's more of a classic way of mapping requirements to verification requirements. So the way I did it is, for every requirement in section 3, which is a design requirement, I created a verification requirement in section 4. So there's an exact one-to-one correspondence between every section 3 and every section 4. You don't have to do it that way. You could simply put the label on every requirement and then handle the other aspects of the verification requirement in another part of Test Center. I did this kind of from an academic reason because I think it's easier to explain this way. It's easier to show the traceability, but that doesn't mean you have to do it that way. And the tool's flexible; it'll let you do it either way. But this illustrates how for every section 3, I have a section 4 corresponding verification requirement. That's section 4 then, and I pull a report now. So I can create within Innoslate, I can create a requirements verification test matrix, RVTM. Oh, sorry, traceability matrix is the T. And so here you see your section 3 requirements. You see your method. This all again happen to be inspection, and then the section 4. And I actually have some shall statements there in the section 4s that kind of lay out the shall be verified by inspection, and then I have a statement of kind of what that inspection means, because it's all well and good to say I'm going to verify something by test. I need to tell somebody what kind of test. I need a little bit more to go on there so I can do my verification planning. The next step then is in defining what I would call my verification architecture. So the thought process here is I'm going to come up with a number of what Innoslate wants to call test suites. And test suites are collections of test cases. So you have to decide based on your project, how many test suites do you want to have? And a test suite tends to be a situation where you have the system in a particular set of configurations. Or if you're building a system, part by part, your test suites may be focused on one particular configuration. And then you're going to decompose those test suites into test cases, as we'll see. So this shows the test suite flow from subsystem acceptance all the way through operational events for our NanoMET project. So within Test Center, the way we do that is we open up Test Center, and which is on the pull down menu, and then you say, give me a new test suite. So you press the test suite button, you give that test suite a name and a number, and now we have a test suite. And then I'm going to start defining test cases that are part of each test suite. So this shows how I broke it down. So I have my high-level test case 100, which is decomposed into 6 sub-test cases, and those are further decomposed into what I call test actions, but they're all part of the same thing. So within Innoslate, this is an action. All of these are actions, but they're handled a little separately and distinctly within Test Center. So obviously the tool doesn't do this for you. You have to know what you want to do. But once you've done it, it captures it very nicely and helps you manage that traceability. So you create a new test case from within your test suite, and then you can create sub cases as well. So it's pretty easy. If you've used Innoslate to create requirements, it's pretty much the same way. So you create a test case, and then you can add after, or you can add children, depending on how you want to nest those test cases. And then you would likely will also want to put in things like your expected results, and you have a place to actually record the actual results that you got from your testing or whatever, and then you can keep track of the status as you go along. So there's other places to record the results, and we can actually do regression testing as well. So we can actually make a new version of this test case as another iteration. So if you want to do multiple regression tests, you can, and make tweaks in between, you can preserve your first run and then look at your second and subsequent runs as well. Part of the grunt work here is now tracing all of my requirements and verification requirements to my verification architecture. So you have your test case that you've defined, and now you got to go into Innoslate and say that, okay, during this test case, I'm going to verify these requirements. And obviously the principal engineer needs to know what's the appropriate requirements to verify during a specific test case. And if you have a lot of those, and I didn't pull a slide on that, but within Innoslate, there's something called a traceability matrix you can pull up. And so you can have all your test cases and say on the rows, and you have all your requirements on the columns. And then by clicking the button, you can pretty quickly map requirements to test cases. So you can keep track of all that. Oh, actually, I did pull a slide on that. So here's my traceability matrix. So this shows my verification requirements, and then there's my test suites along the top. And I didn't show it here, but if you check a box, then that would show that requirement is being verified, or in this case, satisfied by a particular test suite. So this kind of shows you what that ends up looking like. So I pulled a spider diagram for one particular test case, and you can see in this particular test case for NanoMET, we have, I didn't count them here, but a dozen or more requirements that are going to be satisfied. These are verification requirements satisfied during that test case. Of course, again, principal engineer had to know that during that test case, these are the appropriate requirements to satisfy. But once I've mapped that once, I can keep track of it, and it really makes change management, and change tends to be inevitable when it comes to verification planning. It makes change management much more manageable. So let's kind of show you what this might look like then, just kind of tracing one requirement. So I have a design and construction and safety requirement that has a child requirement on shock hazards. So we have a requirement that says all GSE, flight GSE items shall be designated to avoid designed to avoid open voltage sources. And now I have a verification requirement. It says verified by a verification requirement 4136, shock hazards shall be verified by inspection. The inspection shall ensure the battery module connections to the PCB are insulated. So there's my verification requirement. And then now I go down to that particular test case, and that test case, which is going to satisfy that verification requirement, and that test case at the top has a test action. You see the little box there, a little checkbox that says, okay, operator or tester, inspect battery module to ensure there are no open voltage sources. So I'm telling the person doing the inspection what to do. And then I'm also going to give them success criteria. And so that's the expected result that you would enter within Innoslate. And I cross-referenced it there to the requirement. The inspection shall be considered successful if battery module terminals are properly insulated to protect against accidental shorting. So now I've told the person doing the inspection what to do and what the acceptance criteria is. And that's just for one requirement, and you may have hundreds, if not thousands, of requirements that you got to do that for. So now, once I've captured all that, and it is no small effort to capture all that, but the tool makes it very straightforward to do. You can now auto-generate a lot of products. So I can generate a product like this one. It shows me every test case, all the verification that's being done for every test case. So that's a handy thing to have. And so I can pull out my verification requirement and the description and the criteria there, for example. And then what's really useful is you can put out a report. We tend to call this a work order. That's how it's often described in other parts of the industry. Innoslate doesn't call it that, but they just call it a report out of Test Center. But the report is really nicely formatted like this. So you have your test case, your title, you can keep track of your revision number, you have a test proctor who's running it, you have a date, you have a place to record pass fail. You can put in an estimated execution time. This is kind of nice too, because you can assign times to each of these are all actions in Innoslate. So I can assign a time duration it takes for each of these test activities. And then from Innoslate, I can actually generate a schedule. So I can generate a Gantt chart that'll say, okay, if this takes 20 minutes and that takes an hour and that takes 30 minutes, I can generate a Gantt chart that'll actually tell me the schedule for running all that. I capture the test objectives, the test setup, and all the related requirements that I'm going to be verifying. And now I have laid out step by step all of the procedures I'm going to do. And the way we use this is we print it out because we're in a lab and it's just easier to give people paper in a lab. We print this out, and now we have step-by-step instructions that students go through and follow the test action, check the results, record their data, and then we could enter that back into Innoslate. Now we do this over and over again, so we haven't kept track of the pass-fails within Innoslate because we just haven't had a need to. But the capability is there just to record that directly in Innoslate if you wanted to. You could actually run this from within Innoslate if you wanted to. But we've printed it out and used it on paper. And then one of the things you'd want to keep track of overall is something like a compliance matrix, so you can keep track of the compliance status for all your requirements for closeout and that kind of thing. So I want to give you one other example here that we used, where we used Innoslate as part of a test cycle planning together with using LabVIEW. And so the idea was kind of try to show a round trip between verification planning, verification execution. So we did the initial verification architecture and planning, all the test suites, all the stuff I just talked to you about was done in Innoslate. And then we'd actually go do execution of the test itself, driven by LabVIEW. So think about, Innoslate's kind of the model of the models here, where we're using it to keep track of what we need to do in testing. But when you go to do tests, obviously you have other tools that you use, and LabVIEW is one of those tools. And you may go through multiple iterations, and that's kind of what we're kind of addressing here, is how do you handle multiple iterations, if you're doing regression tests using slightly different configuration parameters. So as the example we chose is to do, we have this ability to do an automated bus checkout. So I'll explain that here in a second, but basically we can use LabVIEW to send commands, receive telemetry, send commands, receive telemetry. So it goes through and sends every possible command, and it receives all the telemetry points, and it checks those automatically and tells us if there's a problem. So it's basically an automated testing. So obviously you could have an operator send the command, check it by eye, but that gets extremely tedious when you have a lot of commands and a lot of telemetry points to check. And especially if you're doing it over and over and over again, at some point your operators will shoot you if they have to do that over and over manually. So we automate that. And so, but part of that automation is the configuration of the automation. There's some things you can change. You can change the number of runs. There's what's called a delay time between runs, and there's a wheel run time, because we're turning on a reaction wheel. There's some error checking. So there's some configuration parameters of that automated bus checkout that you can do. And so the way we set this up in Innoslate, that's a manually that would be a step in a procedure, but then we captured that in Innoslate as characteristics of this particular run procedure. And then back in LabVIEW, using Scotty, which is our LabVIEW command and control software, the operators can use LabVIEW to run this. And in fact, within LabVIEW is this automated bus checkout capability. And so if you're running this manually, you would set those parameters manually, and then you would hit run. What we wanted to do is show that you could have that more automated. So I can set this up in Innoslate, export the file to LabVIEW. LabVIEW Innoslate imports the configuration file and then runs the automated checkout. So once I import that into LabVIEW, there's a capability that says execute Innoslate, which basically it's going to go grab the file from Innoslate, set the configuration, and then run the test. So it goes in and grabs you got to go tell it which file to use, and then it's going to automatically update those configuration parameters and start running the test. And then it's going to go through, I forgot how many different parameters there are in this test, probably about 40 or something like that. So it goes through about 40 different steps, checks a whole bunch of different telemetry points, checks those automatically within LabVIEW, and then gives you feedback on that. And then, so once that's all done, you can watch, the operator can watch that during the run. And then during the run, the system itself is running. I don't know if you can hear it there, but I've got a little video playing, and if you look carefully, you can see that there's a wheel that's spinning during the run. So the automated bus checkout is sending the command, telling the wheel to turn on and spin. It's setting some wheel speeds. It's turning it the opposite direction. So it's going through and doing that all as part of the automated checkout. And then at the end of the run, the operator can see visually whether anything failed. But then the LabVIEW creates a run file. So we have the actual data from that run. So this is our, this is our test results, and obviously we want to capture that. So that's a file then that we would want to capture. We want to access that file, and then we would import that back into Innoslate, and we can import that as an artifact within Innoslate. So it's a test run artifact, and then we can link that test run to our particular test cycle in Innoslate. So now, I go back historically and I can go say, well, hey, when you guys did test cycle number 3 and using this configuration, where was the data for that? And I can go find it because I've linked that particular artifact to that test run along with the results. So I model that. This just shows what the data. So this is the raw data file that came out of LabVIEW, and that's what I want to capture then in LabVIEW. I'm sorry, in Innoslate. So I set up an artifact, and I can go into Innoslate and I can upload that file, and now I've captured that data file. So I can now have historical traceability of that. So that's there. Now it's going to be referenced. It's going to be linked back to these test procedures. So so now I have that all together. And then back in the test center, there's my overall test, and I can then put in record the actual results, and I could say simply see data file, and I could say that, okay, this one has passed, and now I keep track of my pass fail, and I've got the link to the raw data. And within Innoslate, let's see, what else did I do here? Oh, I was done recording. So here I am in Test Center, and then I can set up for the next test run. So I can open up another cycle, and I can go up here and say new test cycle, call that test cycle 2 or whatever, and then I can create that, and it's going to copy everything from the previous test cycle, but now I can go in and change my parameters. This now, instead of a run delay of 1 minute, I'm going to do a run delay of 2 minutes. Instead of a wheel time of 10 seconds, I'm going to do a wheel time of 20 seconds. So I now save that. So it'll preserve what I did on the last test cycle, but now I'm going to start a new test cycle. And now I got to go in and go to the characteristics that I have attached to this particular test. And so I have run delay, number of runs, wheel run time as characteristics, and I'm going to go edit those. And now instead of 1 minute, it's 20. Notice or 2 minutes. I notice I'm doing it twice, but I'm capturing it one place in procedures. So I have the documentation of what I did, and then the other place are the characteristics, and those characteristics are what I export as a file that is then used within LabVIEW. So changing those characteristics, and then now I run a report, and I actually used the XML file here. So I export the XML, and we did not take much coding to get LabVIEW able to ingest this XML file directly, so that we could then lay out the configuration for the test run. So then I can see the planning. Oops, I can see the planning for the test cycle. So you can see there the status roll up, passed and failed, and things like that. So you can get an immediate status of what's going on with your testing within Innoslate. So wrapping up then, I would say Innoslate Test Center gives you a whole end-to-end way to do your verification, planning, and execution. I've done verification the old-fashioned way, using Excel and PowerPoint and Word, and you'd have to put a gun to my head to go back doing it the old way, because it greatly simplifies the task of linking all the requirements to test cases, greatly reduces the time it takes to set up and develop your initial test plan, and really reduces the errors when it comes into mapping all your requirements to all your verification requirements. It helps you keep track of that snowball effect I talked about earlier. And you can actually help find all the gaps and overlaps. So you can use the intelligence view in Innoslate, and it'll tell you if you have requirements that aren't being verified by anything. It'll tell you if you have any non-linkages, you have test cases that aren't doing anything. So it'll tell you if there's any gaps in there. And the key thing, I think, is the replan. If you've ever done any verification planning, you go through numerous iterations. And because you make a draft, you show it to people, they say, oh, well, we need to add this step, or what about this, or what about this test equipment? People, it's a team effort to do verification planning, and inevitably you get feedback that requires change, and it's fairly straightforward then to manage that change within Innoslate, especially if it's a major change like an additional requirement or a change in a requirement, which on paper becomes extremely laborious to try to trace through. But here it's virtually automatic. If I go make a requirements change, it's going to ripple all the way through all of my planning. So it makes it much easier to keep track of. And if somebody proposes a change, I can pull up the spider diagram and I can see what's going to be affected by that change before I make it. So I know whether I should even make the change that's being proposed. So it's a massively kind of almost like paradigm shift in terms of how we've normally done verification planning, because it takes a really, really hard problem. It doesn't make the problem of figuring out how to verify any easier necessarily. It makes the problem of managing this light years easier. And when you're dealing with thousands of requirements and multiple test cases and things, you pull your hair out trying to figure out how to make all that stuff line up. And so this is a great tool for doing that. And then last thing I showed is how we can actually integrate with external tools like LabVIEW to do sort of round trip execution between automated testing and then keeping track of results back in Innoslate. Okay, so that was a lot to go through. I appreciate everybody's attention, and we have some time, I hope, then for questions. Joanna, how did you want to moderate that?
Yeah, actually, we'll go ahead and still stay on your screen, Jerry. And we actually do have a couple questions that have come in. The first question is, can you talk about how non-functional requirements are handled in Innoslate?
Really no different. So I'm assuming what you mean a non-functional requirement is more like a system characteristic. And we actually had a lot of those in this example. So workmanship, sharp edges, things like solder joints, quality. Those are non-functional requirements, tend to be verified largely by inspection. And we built those in directly as well, because the verification planning doesn't really care how you do it, or even it doesn't really care what the requirement is. It helps you map what the requirement is to your method of closeout and then keep track of that.
All right, next question. What features, functions are available to make this available and understandable to non-system engineering stakeholders, i.e. management, testers in the field?
Could you read the first part of that again?
Yeah, what features / functions are available to make this available and understandable to non-system engineering stakeholders?
Well, in general, I mean, one of the things I think is great with model-based system engineering is that it gives us lots of ways to display the same information. So if I use this example, this diagram as an example, traditionally you wouldn't have anything like this. Traditionally, you would have maybe a table that would show all this. And when you're trying to talk to managers or other folks that don't necessarily have system engineering background, their eyes glaze over trying to sort through a bunch of columns in a table. Where if I can show them a diagram like this, it's a much more intuitive. Now, obviously, people have to understand basic terminology. What's a requirement? What do I mean by a verification requirement? What do I mean by verification? What do I mean by test? But assuming they understand the basic vocabulary, the tools gives us multiple ways to show the same information and explain it in far better ways than simply on paper. So I hope that answers that.
I think it does. I have another question for you. One question is, will the slides be available to us?
Yes.
Thank you for that. And another question that's came in, how do performance requirements managed here?
Well, we treated performance requirements, going way back. So performance requirements broadly are what I called here system capabilities. Where'd they go here? So I broke my requirements into characteristics, physical characteristics, system capabilities, which is where I put performance requirements, how much, how well, and then I had a third category of interface requirements. Requirements, how to organize your requirements is almost an art form in terms of how you want to do it. Again, the tool doesn't really care how you want to manage your requirements. It gives you the ability to manage them. So any performance requirements, you would trace down just like you would your characteristics or your other requirements. So when we had our performance requirements, like voltage, had to output a certain voltage, then we could go verify that by test, and then we had a test sequence that laid out how to do that.
Awesome. Thank you. Oh, I'm sorry. There's a clarification actually on that question, Jerry. How are performance requirements managed through verification and validation?
Okay. When I say how is it managed, I guess I need to know more about what you mean. How is it managed?
Stand by. We may have to have the user type in their clarification there for us. Through the test center is what they're asking.
So again, I'm not sure I completely understand the question. So the performance requirements kind of come in when I come in here, I guess. So I'm going to have a whole laundry list of requirements, some of which may be performance requirements. Along the top, I have what I call verification architecture. So these will be my test suites, and then you could break that down into test cases. And so when I say, if I understand the question, managing it is, I'm going to take my requirements, I'm going to map those into my test suites and test cases so that test center knows these requirements are going to be verified during this, in this case I called it TC110, this SIS verification event, TC110, I got to tell the tool that it's going to that event is going to satisfy all of these requirements. And that's the linkage, and I can use the traceability matrix to do that, especially if I have a lot of them. The traceability matrix is a convenient way to do that. So this is if I understand the question, this is how I manage the connection between the requirements and the test center architecture that's within test center. I hope that makes sense.
Yes, it does. Next question. What's the best way to communicate your requirements to stakeholders in your experience?
There is no best way. I think because it very much depends on the stakeholder. There's lots of ways. I mean, it depends on the person. Some people like to see diagrams like this. Some people like to see a report that's all in words. Some people like to see basically a spreadsheet. And I think the real message for me out of MBSE is I don't have to pick one because if I do one, I get all of the above. So if you have a stakeholder that likes to see pictures like this, then he or she gets to see a picture. If you have a stakeholder who really, really wants a spreadsheet, you can hit the export button to Excel and you got a spreadsheet. So I don't think what's nice in MBSE is I don't have to choose a best way. I have multiple ways, and frankly, I don't care which way people want. I can give it to them however they want it. Just pick one. And it doesn't cost me any extra. Once I have one, I get the others for free. So I don't have to pick one.
Thanks for that. Another question that's came in. Is there a way to run Monte Carlo through Test Center to get verification on a specific spec? For example, Part A needs to be reliable 99% of the time and has a failure rate, and I run an analysis on it and have the result be populated in Test Center.
That would actually be two separate steps. So within Test Center, we would set up and say that we're going to verify this reliability requirement by analysis. But that Monte Carlo is a separate model, and and you could actually do that in Innoslate. So I would go model that, and I've done that. I don't have these in this set of slides, but I have done Monte Carlo simulation for looking at essentially the same thing, looking at reliability of a small system. But it's not automated to connect that Monte Carlo results back directly into Test Center. At least that's not currently automated. But but the linkage would be very clear, because you could say that verification would be done through this model, and you'd link it directly to Innoslate to that model. Of course, you may do multiple runs on that, depending on how you have it set up, or what your initial conditions are going to be. But the short answer is that you could do it, but it's not automated. So they would be a model within a model. So if you think about the Innoslate as sort of a model of your verification, you'd separately have a system performance model still within the same tool, and maybe even within the same project, but maybe not. But it's not currently set up to be an automated connection.
And Jerry, this is Steve Dam. I just thought I'd throw in that not yet.
Right. There's nothing to preclude that. It's just not currently set up that way.
That's what we're working on.
Did you get a lot of support? Next question, I'm sorry. Did you get a lot of support from Innoslate figuring out how to go about getting things set up within Innoslate and also integrating with LabVIEW?
Let me answer. I'll ask the last question first. So LabVIEW, I work really closely with my LabVIEW developer on that, and it turns out Innoslate didn't need to do anything different. We could take the XML file as is once we understood the nature of the XML file. My LabVIEW programmer turned out, and he'd have to explain directly exactly how he did, but it was actually quite simple for him to do that. It didn't take him many hours at all. He took like 2 hours to figure out how to do it, and that part was pretty simple. I've been working with Innoslate on verification planning for actually a couple of years. So when the first iteration of all of this was done before there was a test center. So test center came out, I can't remember, Steve can remind me when it first came out, but we had all this built before there was test center. So I actually did it before all the nice cool tools were in place. And even then it wasn't that bad, it was pretty straightforward. But test center made it way more easy even than I had done it before. So I did work with Innoslate as I went along to use it. But I would say if you're familiar with verification planning at all, it's relatively intuitive how it's laid out, because it kind of follows the logical flow that you do in any verification planning.
Next question. What other tools aside from LabVIEW can Innoslate interoperate with?
I'll have to defer that to Steve.
Yeah, I thought you would. So a variety of things, mostly through import-export. CSV is probably the best way to interoperate with a lot of the tools, because most of them can have an import of a CSV capability. If you need specific help with something specific, we're glad to help with that. We want to interoperate with more and more tools as we go through the process. And it looks like that's kind of the last of the questions at the moment. I'd like to say one quick thing. I want to thank you, Jerry. Great presentation. Really very interesting and informative, and I understand it better now too, so, which is great. And also wanted to congratulate the folks from the spaceship company and Virgin Galactic on a successful test flight today. That was very exciting.
Oh yeah.
So we're going to take back the thing here if I can figure out how to do it. Get to the right one. There we go. And we're going to take back the presenter role real quick here. We got a couple of quick announcements.
So, and to wrap up on the webinar, thank you to everyone who did ask a question. And of course, we want to thank everyone for joining us today for our webinar. One thing we do want to let everybody know about is we want to invite everyone back on January 23rd, 2019. We're going to do another webinar, DODAF and Innoslate 4.1. That'll be at 2 p.m. that day. So please be on the lookout. We're going to start sending the correspondence out for that very shortly. Another thing is we do have resources that we do encourage everyone to visit. You can always visit our website and blog at Innoslate.com. You can always connect with us on social media through the Innoslate user group or on Twitter using the handle @Innoslate. And of course, lastly, from everyone here at SPEC Innovations, we just want to wish everyone a happy holidays and a happy new year. So thank you everyone again, and we hope you have a good rest of your day.